Sink down and emotions feel like I never did before. Live shows and spoken reels of the movie I ignored. Blue skies on a broken sea and I'm stuck up on the shore. I never thought you could see me, but you did. All I know is we're here, that they took us somewhere. So what they say we're called is falling out of line. They don't know the two of us are colorblind, yeah. All I know is we're here, that they took us somewhere. So what they say we're calling falling out of line. They don't know the two of us are colorblind. All I know is we're here, that they took us somewhere. So what they say we're calling falling out of line. They don't know the two of us are colorblind, yeah. So easy. We could be the enemy and show them how it's done. Yeah, we could brand a new identity and tear apart the song that's making grayscale with a black and white scale. Singing saints that the sinners believe and burn all that's in it. We'll take them out. We'll make them up for it and shout. Keep out the guns, I'll take the wheel. How we feel, we were made for this. We be mountains still and make it real, make it dangerous. Been colorblind for all my life, and they kept painting rainbows. I'm colorblind, it's black and white. It seems it will remain. And you've been colorblind for all your life, too scared to even say so. We're colorblind, it's black and white. It seems it will remain so. So what they say we're called is falling out of line. They don't know the two of us are colorblind, yeah. All I know is we're here, that they took us somewhere. So what they say we're calling falling out of line. They don't know the two of us are colorblind. All I know is we're here, that they took us somewhere. So what they say we're calling falling out of line. They don't know the two of us are colorblind, yeah.
You just walk right out the door. Don't wanna do this anymore. Now I'm lost without you. You drive me crazy out my mind. How'd you do this every time? Now I'm lost without you. You used to be the one I talk to when I'm sad. Can't you see now tainted love is all we have? Our issues run so deep, now when I try to sleep I feel so bad. I should leave and by the time it's done I'll be gone. You're so distant when you're home, always hanging by your phone. Do I even know you? And I get paranoid sometimes, 'cause I know that you ain't mine, and I'm lost without you. You still be the one I talk to when I'm sad. Can't you see now tainted love is all we had? Our issues run so deep, now when I try to sleep I feel so bad. I should leave, and by the time it's done I'll be
Hello, everybody. We are back for Wednesday hacking practice. Continuation of all the previous hacking practice streams that I've done. We are working on the Nightmare course from Guy in a Tuxedo on github.com, or has a repo on GitHub. Last couple streams we have been in the return-oriented programming section, the ROP section. We got through all the ones that involved, I guess, a partial overwrite of primarily return values. I guess, yeah. And this is the one that we did in stack pivoting is when we had a partial overwrite of the saved base pointer, which is what allowed us to do what I guess they have termed stack pivoting. So we controlled where the stack got to after a leave instruction and a return and then another leave instruction. And from there, we were, with the stack pointing at our input, we had the ability to just go through our ROP chain. And we learned about using what I guess is termed a ret slide in order to handle the fact that we weren't sure exactly where in that stack buffer we would end up. Okay, so we're just going to move on to the next one. It's still in the stack pivoting category, and this one is from Insomnihack 2018. It is the one right challenge. Uger Sins, yes, I see your messages. Sorry, I was looking at OBS, so I didn't see that. Thanks for the follow. Do you hacker? I'm assuming that you mean, like, do I hack things? And I guess from the standpoint of, like, do I break into computer systems that I am not allowed to break into? No, I do not do that. And I don't like do anything professionally for this, so I don't work as like a pen tester or a red teamer or anything. Right now, I just work on these sort of what are called CTF challenges. So they're programs that are built with the intention that somebody be able to hack them, so they have a vulnerability, and it's basically used for practice and competition. So I am trying to get through this whole lot of challenges that are in this repository, and it's good practice for me, basically. So that's what I've been doing, and I haven't really applied these skills within the larger context of hacking into a system yet. Certainly I wouldn't be doing that again when it's a system that I'm not authorized to break into or anything. But you know, it might be fun to set up a machine and have some kind of vulnerable software and go through the full process of enumerating that, finding the vulnerability, writing an exploit, and getting into it, and sort of like mimic the concept of developing a 0-day, the sort of thing that they maybe play up in hacker movies and television shows and like Mr. Robot and all that. On the streams that I do, the closest thing that I have to that is on the weekends I do Try Hack Me boxes, and Try Hack Me rooms generally involve the full process of like, okay, here's a machine, go run Nmap on it, see what it has. Generally it's a web-based attack that you're doing, and so I've started doing those over the weekend, but it's been very like minimal stuff so far, and mostly things where it was explained what I had to do. So it's very, you know, early stages on that, I guess. But in theory, these techniques and the things that I'm practicing here could be used within the context of exploiting a real world piece of software. I think doing so, finding an exploit in a real world piece of software, like finding a 0-day or something, would not be something to stream, because that represents a kind of disclosing that vulnerability in a non-responsible or an irresponsible way, I guess. So what I would like to do is get to the point where I'm looking at existing, you know, previous 0-days or previous vulnerabilities that have been published that are already fixed or have patches available for them, and then attempt to actually recreate and generate a proof of concept exploit for those, just for the added experience of working on real world software. But I wouldn't be doing that for stuff that was unknown, I guess. All right, the one right binary, I've copied it in, so let's take a look at it. It is a 64-bit binary, dynamically linked, not stripped, and has debug info. So that, I mean, we don't have the source code, but might help to see what's going on in GDB a little bit. And what is it linked with? What? It says dynamically linked, and then I look at it and it says statically linked. Did this happen before when it was... No, I think I got a different message when I didn't have the right, like, interpreter binary. So I don't know why it says dynamically linked from file. But if we look at checksec, you can see what the security settings are. It's got partial rel-row, canaries, NX, and PIE. So either, based on my previous experience and what's coming to mind right now, we have maybe one of 3 possibilities for exploiting this. Canary is on, so that's going to be difficult, because we won't be able to just overwrite EBP or the saved base pointer or any of the return addresses, because those are going to be stored after the canary. I mean, we maybe have a scenario where we can brute force the canary somehow, or it's leaked or something. But otherwise we need to overflow and write something else that's in the stack frame and not touch the canary. See, and then obviously NX is enabled because we're in the ROP section, so we're going to do ROP. And with PIE enabled, we either need to leak addresses that will give us libc or the main binary base address or something else potentially. Foon 123456. Hello, how's it going? So check look. How you been? I am. Let's see. Sorry, I got distracted for a second. I'm doing good. Just been keeping up with this stuff. I know that my new schedule is probably not very conducive to a lot of people because if you're in America, it's just real early in the morning. But I've found that getting a bunch of work done earlier in the day and then feeling like I have time to just do whatever on the stream for my evening is working a little better for me right now. Maybe when I have less work in a couple weeks, I will switch back to doing the morning streams. I don't know. It's definitely clear that there were a lot more people that were around when I was doing the streams at that time, and it's fun to have people around chatting and stuff. But I appreciate you popping in now on however early it is your time. Okay, so just sort of spitballing about what possibilities we have for exploiting this. So maybe we leak an address. Maybe we could leak a stack address, I guess. That's fair. And maybe we have access to the old vsys calls, which is mapped at a fixed address even with ASLR and PIE. We saw that in an earlier challenge, but I bet that's not what's gonna pop up here. So yeah, if we supposing that we're leaking some useful address, we still would need to deal with the canary unless our mechanism, like the canary means that we're probably dealing with overwriting something else in the stack that then maybe gets, I don't know, we'll have to see. Because with this many protections on, our options are a fair bit more limited. So I'm gonna go ahead and run it first. Oh, there we go. So we get to choose what we want to leak. So we could leak a stack address. Yeah, please lurk. I'm always happy to have people lurking. Okay. So it's an interesting interaction. And if we leak a PIE address, okay. Yeah. Not sure on what all is going on with the address they were inputting in the data, but we'll check it out in radar and see what we can see. Oh, right, because it's statically allocated or statically linked. So we turn off buffering for standard in, standard out, and then I was so distracted with the menu options, I didn't see that it outputs. All you need to pwn nowadays is a leak and a keyword write, they say. So I guess that's, you could, yeah, if you have the one gadget thing and you leak a libc address and you're lucky, I guess you can get away with that. So maybe that's what we can do. Okay, so the whole meat of the thing is in GC, or do leak rather, which I can get to from GC in the radar commands. And let's see. So this will be for us leaking a stack address, and this will be for us leaking, I guess, a libc address. So we are putting something from local 8 in there, and local 8 is, no, this is, I don't know why it's calling this libc TSD locale. So what we've put into the local 8 variable basically is the address of this function do leak, and from there we could, you know, determine the address of any other spot in the main binary. Oh, but this is statically linked, so we've got all the libc stuff in here. We could see if we have system or something. It's not going to be linked in if we're not using it, and I don't know how one gadget would be able to respond. It'd be interesting to run it on this binary, see if it finds anything. Okay, so it doesn't have the bin sh string, so probably we haven't linked in this, like we didn't call system anywhere in this code base, so the static linker has not linked it in. So we can't do something that simple. Okay, but that feels like the more useful thing, but I mean, there's definitely the potential. Well, let's see. We can leak a stack address, and then, I mean, this function does not have a canary, so maybe you know, this is sort of a heuristic, I guess, and since it's statically linked and most likely the libc functions are going to have stack canaries compiled on, then it's just finding some of those and determining, okay, there are stack canaries at least in some of the code, but this function has no canary, or at least it has no check for a canary. I didn't look at the top. But yeah, we're not getting the canary value from anything. So supposing we just leak RSP effectively, and that gives us some potential depending on how much we can write, because this is in the stack pivot category, which is, broadly speaking, how Guy in a Tuxedo has decided to categorize these challenges. And so maybe that indicates that when he solved it, he went with the stack approach, used that to overwrite. I mean, yeah, he could have overwritten EBP so that at some point, maybe in do overwrite, it calls leave or something. No, we aren't really, we're not using base pointer at all. So I don't necessarily see how we would be able to do the same stack pivoting thing that we did on the previous one, the speedrun 4 challenge, because that allowed us to effectively control the value that got put into RSP, whereas we're getting the address out of RSP and we can write to the memory at that address, so we could certainly control where things return to, which is the standard ROP approach, but we don't necessarily, because we aren't pushing, we're not setting RSP to something else, then we've only got control over that one entry, because I think what we're doing is Yeah, it looks like we are writing 8 bytes, or we're reading in 8 bytes to an address that is whatever address we provided up here. So we get a single keyword, right, just as it says in the sort of intro text. We get a leak for an address, and then we can write 8 bytes to any location that we want. And so we need to work out how to make that a full exploit. We could look for gadgets. But we would need, since we don't have the ability to write a bunch of stuff, we would need a single gadget that does what we want. And I just feel like there's no system function. Not that we would even be able to input something that would have the parameter to system in the first place. What can we go to? What can we use that would be work for like an entire ROP chain, basically, or whatever, there's got to be something more advanced than what I am trying to think of, which is the equivalent of saying like jump to a certain function, which is just some of these earlier challenges. They aren't categorized specifically, but I think they were just like go to a particular function. Like this one is in the buffer overflow call function thing, where basically you're overriding the return pointer to return to a different function that's equivalent to a very simple ROP. I think we need something more advanced than this. We could return back to like main, so we can repeat the cycle. So if we leak, can we? Since we only get one or the other, if we leak the stack address, that allows us to write to whatever would allow, if we leak the stack address, then we can overwrite the return pointer and get control flow. Like, we can define the control flow from there, but we don't know what address we want to write into the stack pointer, since we can't jump into the stack because NX is enabled, and that's not a heuristic, that's just like you can see that from the permissions on the segments. So we can't jump to the stack, and if we only leak an address of the instructions, and with NX enabled, all of those instruction sections, the mapped in segments that contain them are going to be read execute, not read write execute. So that is difficult. Because how do we make use of, like, we kind of would want to have both of those pieces of information. Rather tricky. Or let's just go back to main. So, is there anything interesting in here? Not really. If we pick neither of them, it won't leak us an address, but we will still do an override. I don't think that helps us at all. But it's interesting that it doesn't quit out. It still is going to prompt for an address and data. Okay. Yeah, that's weird. Or not weird, but it's just like it's hard to know. What am I saying? GDB one right. So we do have the vsyscall section. So that's a fixed area that we could jump to. If we leak the stack address, then we can calculate the right place to write such that maybe this return or even the return from the calling function, we can get that return to go to the syscall or somewhere within the vsyscall section, but we don't control the registers that are going to be used. So read is going to return the number of bytes probably. Yeah, so that's going to have 8 in it. So racks will have 8 in it, which is probably not a very useful syscall. Syslseek, I don't even know what that's about. It's a file seek. So yeah, that doesn't help us. So jumping to a syscall from here doesn't seem to get us anything. And there's really very little else in the vsyscall area that I'm aware of. So definitely having trouble coming up with an idea for how to exploit whatever the exploit the write. It's not even a vulnerability at this point because it's literally the thing that is the intentional coding of the program. Who do you think makes the best fried chicken? I think you're gonna have to narrow down the options. There's probably some individuals out there who make some really good fried chicken. Which engine do I use for game dev? I haven't really done much game dev. Do you mean the like when I was when I worked at a game company, we used a proprietary engine that was, I think it might still be around, but it was used for some games like I think it was called like Marvel Ultimate Alliance, old ones. Yeah, back in the day, I think. Could be misremembering this one, but oh no, this is not the one. I think they were games by Vicarious Visions. Some of their games, they had a Marvel one back in the early 2000s. Oh, it was Ultimate Alliance. Okay, yeah, so, or maybe they used it for this, but I was thinking probably some of their ones for like Xbox and PlayStation. I thought. I don't know. But it was a particular engine, the Alchemy engine that they created or bought, I guess technically. It's not necessarily like just something you can go pick up. And it was written in C++ primarily. They had Lua as an option for scripting it, but we ended up not using the Lua stuff for whatever reason. But you know, Unreal 4 is probably a good way to go. Unity is probably also good. It sort of really depends on what your needs are, I think. And if if you're just gonna make something, if you're thinking of making a chess game, I mean, there's definitely lots of ways to make chess. The core of a chess game is the chess logic, the rules of where pieces can move and when you are in a win state or when you're in check or well, checkmate is the win state, but you know, if you're tied or checkmate, or I guess stalemate is the tie rather, or if you're in check and you need to restrict what moves are allowed as well as which pieces can move where, then you've got the mechanics of it, right? You could do all of that in JavaScript and make it a web game, right? Like Lichess, however you pronounce it, Lichess. You can do Is this a live game that we can watch? Right, these people are playing chess right here in the browser, so this is not using SDL or Unity or anything of that nature. It's almost certainly just all JavaScript. Well, maybe it's implemented on the server, but you could certainly do it in JavaScript on the server, or in the client side, I guess, as well. So if you want to make a 3D version of chess, then you are looking at more like using a 3D engine. But a 2D version of chess, or even a text-based one, since there is a standard language for referring to moves, you could make it a console program if you really wanted to. I don't think that would be everybody's idea of a good interface, but just conceptually, so you got to sort of pin down the definition of what you want the game to be before decisions about what language and engine and stuff end up making the most sense. Because if you just say, oh, what should I use to make a game, and somebody says Unity because that's a very popular thing, but really you want to make a program like this, which is just a 2D thing, that might be way overkill. So figure out your requirements first, and then go from there to what your potential options are. And yeah, you could definitely use Pygame. There's for something like chess, which doesn't need to be a super fancy 3D program with lots of advanced shader kind of stuff, like you've got a lot of options for how to do it. But if you want to make a 3D thing and you want to have really, I don't know, super high quality chess pieces, I guess, with like you can make them all wood grained and have normal maps and stuff, so you can see all the bumpiness of the wood, or some or if you wanted to make real animated characters, you could you could make an RTX chess game, right? You could make it ray traced and all that. Like, it just depends on what it is you want the game to be. And keep in mind, if you make a ray traced super high quality chess game, like, most of your time is going to be spent on the graphics versus the implementation of the chess stuff. And if that ends up not being what your interest is, like, you're probably going in the wrong direction. So yeah, if your main focus is like, hey, I want to learn how to make a chess game, I want to make a game and I like the rules of chess and I'd like to be able to implement those, I would say minimize the graphics requirements as much as possible. Make it a text-based thing to begin with. And if you're familiar enough with chess that you could really properly interact with it just using that like text-based readout of what all the moves are, having a version that does that first will let you get the rule set and the game logic implemented without having to worry about any of the visual representation. And then you can add on a 2D representation in the browser or in Pygame, or you could still do it in Unity or Unreal, but as Foon says, it's I guess way too dank. It's definitely not necessary. But it all sort of just depends on what your personal goals are. Which I feel like a lot of the questions I get, my answer tends to be like, well, come up with more details of what it is you want to do. But I don't want to give just like a toss away kind of piece of advice that ends up not being useful because I was assuming something about what your goals were versus what they actually were. Like, you probably have an idea in your head of what you're thinking when you say I want to make a chess game, but I don't know what that is. So it's hard for me to, I don't want to just assume that what I'm thinking is the same as what you're thinking. Just a simple one? Do you want to display a board and stuff? And then show the shapes for all the pieces and have like you can click on one of them and then click somewhere else to have the destination for that move. In which case, yeah, Pygame. If you want to, if you're decent with Python or just want to learn Python or whatever, I think Pygame probably gives you all the pieces you need. I think that is built on top of SDL, if I remember correctly. It's like it's implemented on top of some C-based well, we could look it up real quick. I haven't looked at it in a long time, and I never actually built anything with it. Just about. Yeah, it's built on top of SDL. Yeah, so you've got a lot of capabilities there for doing graphical stuff, doing audio, having input mechanisms. Granted, chess could probably be done purely with mouse clicking and stuff, so you don't need really advanced control for like being able to work with a joystick or a controller or whatever, but it's there if you want it. I guess a joystick version of chess would be interesting. If you have to move a knight or whatever, you gotta like forward left on your joystick to do, or do left first and then forward, depending on exactly which version of the move you're doing. Yeah, you do console chess. So, or you could, if you want to get real crazy with it, there's a series of games, I guess, I think called Steel Battalion back in the day, and I think they shipped with a really like absurd controller scheme. Yeah. So you could have this, and when you move your chess piece, they're all mechs. So you have to pilot your mech to the right square for that move, and you add a little bit of mech control in there. I guess it wouldn't be mech combat because unless you're moving to take a piece and then you have to fight it, but you're gonna win because that's the rules of chess or whatever. I don't know. Or you can make a new version of chess where you can only take the piece if you succeed in destroying the other mech. Yeah, I don't know. I don't know why they decided to make a game and like also require you to buy this thing to play it. But there you go. You could pilot your mech with multiple joysticks. I never played this game. I don't, but I just remember hearing about it. There was in the 90s, and this was maybe in the 90s, but probably in the early 2000s, just so much more interest in physical representations of machine controls, like getting a flight stick or getting a racing wheel. They obviously still have them now, but it felt like a larger part of the gaming audience was like into that than they are these days. Maybe they have a VR version now. I don't know. This would be the kind of game to do in VR, I guess. I've always wanted to do a VR project where you're wearing the helmet and you can see whatever you're in this case a mech or a spaceship or something, but then you also have a physical version of the same console that you're interacting with. So if you were to reach forward and flip a switch, you would actually feel that there's a real switch there because there is a real representation of it in the world, in the physical world, and that would really heighten the immersion quite a bit. And I think my idea was like, then you could use those Kinect things that they used to like. I don't know if they still sell them, but I had some Kinect dev kits for a little while, and if you hook up enough of those, they could track your arms, I'd say, relatively well. and you could then get your arms in the VR thing, and you could see yourself like reaching out and flipping a switch or holding the joystick or whatever, and then also still feel it because you're interacting with a real version of that. And that would be a very interesting experience comparatively. I don't know what's going on here. It's gotten real bloody for a second. Okay, so good luck with the chess game. I would say, keep it simple and always keep in mind what your vision of the project is and use that to drive your decision making. But yeah, something like Pygame should be enough to do a simple chess game that's 2D and uses the mouse or whatever for controls. Let's see, we can write but we can't overwrite RSP itself. At least I don't think we can. I don't see how we would be able to. So we can write to an address here. And we add to RSP, but we don't move anything to RSP. And then when this finishes, we again add to RSP. Excuse me. And then this finishes, and we again add to RSP. So maybe something that calls. Oh, there we go. This calls libc start main. Which is eventually going to call its parameter, right? Let's see. So it's the first parameter. It's the address of main. What do we do with that? We put that in local 18. We have something else at RSP plus 100. It's interesting. I guess that it would be the first parameter. Okay, so put that into racks. Gotta find that call. I'm just blind or something. I don't know why. Doing an indirect call to, is it init secure that does the actual call? Sorry, I wasn't paying attention to chat. Makes you feel very dumb. I mean, in like, if it helps at all, I'm also feeling very dumb with this right now. So, you know, this isn't all like real obvious to me or anything. And I have no idea what I should be doing to solve this challenge. Whew. But one of the things that I saw, so I can explain in a little more detail, entry 0 is the actual entry point of the program. So when you launch the program, when it gets loaded by the kernel and it starts up its own task for it, its own sort of thread to initiate the process, this is the first instruction that executes, and then the second, and etc. And what this normally does, because this was compiled as a C program, the C compiler adds some stuff from libc, which is the C standard library. And one of the things that it does, like this part gets added by the compiler. This is not your main function. Even though if you learn about C, what you're taught is the main function is where the program starts, all of this stuff is actually happening before main as a sort of setup that is setting up things that are defined in the standard for how the C language works. And because the C language says this and that and the other thing happens before main, the compiler has to generate code to achieve that stuff. And for like glibc, the GNU standard version, standard library version, which pretty much almost all Linux programs will use that, they have something called libc start main, and it's basically a function that is doing a bunch of stuff in order to start the actual main function. And what we can see is it is passing in as its first argument the address of the main function. So it puts that in RDI and then calls libc start main. So what I was thinking is that libc start main at some point would end up calling that. It's probably not going to say call RDI, but it might save it into a stack variable and then say call the value from that stack variable. So it's going to do an indirect call to eventually run the main function. Basically, it's written as like so it might be like int what is it, int argc and then you would have and then you might do like and like this. What am I doing wrong here? Oh, we need to like type def. There we go. So this is some C code that says there's a type called main function, which is a function that returns an integer and takes int argc and char pointer argv. And libc start main is a function that takes a pointer to one of these functions effectively. And you know, in this case, it just sets up an empty argv and calls that main function with 0 for argc, oops, and the empty array of char pointers for argv. So, you know, and it does a bunch of other stuff first, like it sets up various things. There's stuff in the C standard about calling these init functions and all that. So what I'm looking for is the bit of code here that's been the equivalent of call R8, because it takes RDI, which is the pointer to the function, is the first parameter, puts it into R8, and then says call R8. So I'm looking through this code for the call instructions, and we've got call to a known function called relocate static PIE, DL auxiliary init that initializes, oops, what did I do there? Oh, geez. I don't remember what DL aux init is, but there's a auxiliary section in the early stack frame. The stack frame that is set up by the kernel before the program starts running, which is what includes the arguments and the environment variables and stuff. And there's an aux section in there. So maybe it's working with that. But basically, then at the end it calls libc init secure, and so I'm just guessing that init secure is where stuff happens, because I didn't see any other call instructions. There's like call assert fail, that's just like an error case. So if we look in init C and we get the colors back, that is actually, if we go back one, do we pass anything? We add something to RDI, but RDI was already set based on some other stuff. Yeah, so it like doesn't, like, I don't think we're passing the main function as a parameter to libc init secure. Yeah, you're not really familiar with C. I mean, this is all very like specific to how C does things. I think if you were, there's not really that many programming languages that compile to native code directly, right? C and C++ are going to work in very similar ways just because of the way C++ is designed or was sort of specified as building on top of C. A lot of this stuff is going to be repeated in the way C++ programs work when they start up, but then maybe Rust and Go would do things differently in their startup. They aren't restricted to doing things in this fashion because this is very specific to the C specification, like the language specification. But yeah, it doesn't. This one also doesn't do any indirect calls, so I don't understand how we get to the main function to begin with. So let's run it in GDB again, and we'll just put the breakpoint at the beginning of main, and we'll run it. And let's see, do we have a stack? We don't really have anything on the stack, so if I say finish, oh, this is the outermost frame? That doesn't make a lot of sense to me. So if we go to, right, this doesn't call exit at the end, so you're trying to get into cybersecurity, what do you suggest that you, what do I suggest that you do? And are CTFs too complicated for noobs? No, I don't think CTFs are too complicated. I mean, the things that I'm working on right now are not necessarily particularly newbie friendly, because it's building on my experience, but it's building on a lot of experience that I have as a software developer more so than infosec specific stuff. Not that you couldn't learn this stuff without doing software development, it's just that that's how I gained these skills in large part, and sort of like doing random reverse engineering on video games that I was trying to like hack some sort of basic cheats or otherwise like mess around with. So but the thing with CTFs is there's a lot of variety of challenges in them, and a lot of them are designed for people that are new. I wouldn't suggest going and playing like the DEF CON CTF, for example, because that is, that and a handful of other ones are fairly focused on more experienced people. But there's one coming up, I think, in August, the Google CTF. They do one every year, and they have like a beginner track. So I think it would be worth trying that. I've found it to be moderately difficult towards the end. The earlier ones are definitely easier, but the difficulty can ramp up quite a bit, while still being somehow not as difficult as the real thing apparently. But I would say you could probably, without any real infosec experience or whatever, or cybersecurity experience, you could definitely do some of the early ones in the last couple of years, and I assume they're going to repeat that with this year. And then there are just other CTFs that are, again, more entirely focused around developers, entirely focused around new people, basically. And basically what I would say is definitely do CTFs, and don't get too discouraged if you come across one that you don't understand how to do. Not knowing how to do it is a part of how it works, I guess. And so maybe you get a challenge, you don't know how to do it, you set it aside and you work on a different challenge. And then at the end of the competition, because they're only a couple days long usually, you can then go and see other people hopefully have written up their method of solving the CTF or solving the particular challenge that you were working on. And so you can read what they ended up doing, and now you know a new thing to try for the next one, basically. And so even if you don't figure something out, you end up, if you do a little bit of research and read other people's write-ups, you get more knowledge to apply in additional CTFs. And then the more you do, the easier it gets. That's just, so I don't want you to look at it as like, oh, it's too much, I shouldn't bother doing it, because if you don't do it at all, then you aren't going to get that experience. And I think this is good experience to get. And I think a lot of people, if you're looking to get into a cybersecurity infosec career or whatever, there's definitely a lot of people that appreciate somebody who's interested enough and curious enough to put in time working on CTFs. Even if the particulars of any given CTF challenge don't necessarily apply to the job, it sort of speaks to your interest level and your motivation. And so I think it looks good from that standpoint as well. So yeah, it's like, you can take that sort of mindset for anything. Like, if I wanted to learn how to play an instrument, I can go listen to somebody. If I wanted to learn how to play the piano, I can go listen to Claire de Lune, which is one of my favorite songs on the piano, and be like, oh, that's too hard, I couldn't do that. But that's not necessarily where you start. And if you decide not to give it a shot because the end goal seems too difficult, then you're never going to get any portion of the way towards it. If I don't play the piano, I'm not going to get any good at the piano, even if playing it in the beginning is very difficult and I suck at it. You just gotta, there's a cartoon show, Adventure Time, and one of the earlier seasons, there's like the dog character, and he had a quote that was like, sucking at something is the first step to being good at something. And I just keep that in mind as much as possible when you're learning a new skill. I mean, that's what I'm doing on this stream right now. I've been looking at this challenge for basically an hour now, and I still feel like I'm 0% of the way towards understanding how to solve it. So, you know, I'm solidly in the camp of sucking at this one right now, but I'm going to just keep at it basically. And like on some of the previous challenges, if I really get to a point where I can't even think of another thing to look at, I will look at the write-up that has already been done and read a little bit. So, you know, I might like go over here, read a little bit of this stuff. I'm not reading it right now, but I'm just like, maybe I'll get down to here, the exploitation thing, and they'll mention something that gives me an idea. And then I'll stop reading because I want to try, oh, that gave me a bit of inspiration. Let me see if I can figure out how to solve it with that little hint. And I feel like that's a good way to deal with a write-up as well, because you don't have to treat it as all or like I do the whole thing myself, or I just read the, you know, the entirety of the like walkthrough. Maybe like playing a video game, right? Maybe there's a portion that you get really stuck on, and so you go to the game facts or whatever. I don't know what people use these days. And you read the little walkthrough for that section, and then you go back to playing the game yourself, because the more time you spend doing it yourself, the more you are getting good at it. And in the case of the game, the more it's just you're having the fun rather than like following a set of steps. So you can apply that same logic to a write-up. You don't have to read the whole thing. You could read just far enough to maybe get the hint that pushes you to, okay, now I know what I need to do. So, you know, I might end up doing that with this one, because I'm sort of just like wandering around. Oh yeah, I wanted to figure out what happens, I guess, when we return, because really I want to figure out what's the instruction that executed just prior to this one, but GDB doesn't give me that. I can't go backwards one, unfortunately. So what I'll see maybe is what happens when we return. And we can put the breakpoint on this return line, which is main plus 86. So we'll do that, and then we will just continue through the program. I'll say 1, and I'll do an address of that, and I don't know, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then we got through to the ret, and if we do ni for next instruction, that takes us into libc start main at this at plus 775. So that's interesting because we are in libc start main, but radar was not able to help us. It was not able to tell us how to yeah. So I think this is just a failure of radar. There is probably more stuff after this function call, and it somehow has decided that this is the end of libc start main, and that is kind of frustrating because I would like to see what all is happening after this. I guess we can try to go just to the call and say, yeah, define that. Okay, and then it just calls exit afterwards. So do we move anything into RSP? So what I'm still looking for is, because this is in the stack pivot section, and the way that we solved the first one in the stack pivot section was that we were able to end up controlling the value that got into the RSP register. Meaning, the next time we hit a ret instruction, we could we would like have RSP point at our ROP chain basically. So then from then on we controlled the sequence of things that happened. But I haven't seen anywhere that we like move a value into RSP. We just add and subtract from it, which doesn't help me, I think. If it does help me, I don't understand how. But one of the things that the C language standard defines is that when you call exit, which is either you write your code to call the exit function directly, or it just automatically calls exit after the main function ends up returning, then it goes through a list of exit handlers, basically. There's an array stored in memory of pointers to functions, and it will just run each of those functions. Things that maybe need to like clean up various resources or whatever. So you could register your own function to run at the end of the program. So we could write an address into there, but again, we don't know an address to write, because we also haven't leaked the memory segment that has the code in it. We don't know where that is in memory, so we don't know what we would write. But we might be able to do a partial write or something. Wow, this is a lot of code. I don't know what the hell any of this is doing. It's like locking stuff. So maybe this is where we do the call to one of those exit functions, because we've put a value into RAX. Oh. It looks like, yeah, it's a bunch of locking stuff because we might have a multi-threaded operation of libc, and I don't know. I also don't think I would have the address of the array of pointers for the exit functions. Let me get R12. R12 is RSI. Which is yeah, this object exit func. If we look for that, I think it is, that's at an address location that we wouldn't, like, it's going to be rebased somewhere random by the ASLR system, so we don't know where the exit funcs array is in order to put our values in there. And it also kind of looked like they maybe are like keeping it how to put it, not exactly encrypted, but basically they're using either a stack cookie or another randomly generated value to modify the actual exit function pointer values in memory so that you can't easily overwrite them, because you'd have to know what that random value is. It's like XORed with that, it looked like. So that's another safety measure. It just doesn't feel like this is the route to go down. I think I am moving further away from whatever the actual solution is. But I also didn't see anything in main. Like, there's just not actually anything that happens after the call to read other than, you know, we return from stuff. And we can control where we return to, but we wouldn't know where to tell it to return to. So I guess I'm going to look at the walkthrough. So can't think of anything right now. I see. Okay. So the bit that I read that gives me a hint is, I mean, it's not even really a hint. But they say the first thing we'll do is we'll use a partial override to call the do leak function multiple times. I don't know why it hadn't occurred to me to do that, because I had been thinking about doing partial overrides because that was what we were doing in the previous section. So when we don't actually have a leak for addresses we can jump to, because we have a leak for the stack, so we know where we can write to control or to get control over the execution flow, but we don't know where to direct the execution flow to. What we could achieve is basically we write 8 bytes, but we don't have to overwrite the full 8 bytes of the area in memory where the like on the stack where return is going to return. Let me step back for a second because I feel like I'm not explaining this very well. When we get to the return instruction right here after the read call, whatever RSP points to, the 8 bytes in memory that are at that location are going to be the address of the next instruction that we execute. It already has the address of this NOP, basically. the place to come back to after the call. We don't know what the top 6.5 bytes of that address are, because they are random, effectively. I mean, we probably know that the first two are null, but there's a solid like 4.5 bytes worth of stuff that we don't know where it is. I guess these are actually stack addresses, but like this stuff is essentially random. So we can't overwrite that data because we don't actually know what we would have to put there in order for us to jump to a location that we control. Instead, we can just overwrite the low byte, basically. So if we know that we're going to come here, and if this address at the top of the function, this first instruction, is within 256 bytes of this one, roughly, it has to be relatively close, let's say. But if it is close enough, then we can get away with just overwriting the lowest byte. If it's a little further than that, we might have to overwrite the lowest 2 bytes, which then, because not all of those 2 bytes are non-random, we do have a little bit of like, we have a 1 in 16 chance of it working, basically, but we could definitely repeat our attempted exploit enough times to get that 1 in 16 chance to work out in our favor. So that's what we can do. We can do a partial overwrite of the lowest couple of bytes and say, oh, rather than go to NOP, go right back up to the beginning of this function. And at the beginning of this function, then we'll continue again and we'll say, okay, now leak me the PIE address. So now we know the stack and we know the PIE address. We could basically repeatedly loop through we could, at that point, we could probably have it return to in here and just repeatedly, can we write multiple addresses like that? Oh, I'll have to think about that. But if we can loop through the read call multiple times, then we could write enough memory onto the stack to do a ROP chain, I guess. Well, we can get started on that process, I guess. Am I running Linux native? Yeah, so Linux is the host OS on my desktop. I wish that I could do more gaming. I actually have built my computer specifically to be able to do this GPU pass-through thing that you can read about, where I can run a Windows VM and I have a dedicated graphics card that I pass through into the VM, so I can do effectively like full speed use of the graphics card, and so I can definitely run games. The problem that I have right now, though, is I also took a risk on setting up um, a non-standard file system, basically, and QEMU, which is what I use to run Windows and then do the games inside of there, seems to cause it to lock up. It causes it to like have a deadlock in the file system. So at some point, after enough time of running QEMU, depending on how intensely I'm using it, basically, the computer will stop being able to write to the hard drive entirely, and I just have to like force it to start shutting down and then usually hard reboot it, which really sucks. Yeah. It's my bad for making that choice. What I was trying to do, because this file system is called bcachefs, it's a really cool file system, and at some point it'll probably be ready to go. And I was a little bit tricked in the website saying that it seems like it's ready to use because he uses it on his main computer and stuff. And I was like, okay, that seems decent then. And in fairness, it has never lost any data. It just sometimes my computer dies and I have to like restart it, and that's really annoying. But it's never actually like come back and the file system was corrupted or I lost a bunch of data or anything. So to that extent, it's been really, I appreciate that. But yeah, the one of the things that you can get with it is like I have one of those M2 NVMe drives, like one of those super fast. Essentially, it's an SSD, but it's just like running on the PCIe bus, so it's super fast. And then I've got a much larger, and that's only like 500 gigs. Maybe it was a terabyte. I don't remember how much I got. And then I've got like 6 or 8 terabytes of like magnetic disks that are much slower. And the idea with this is I can have one file system that spans the whole thing, and it will cache data on that M2 drive, whatever data I am using, so that I can, in theory, have relatively quick access to everything, assuming, it's slower access to something that I haven't used in a long time. But if I am playing games a lot or whatever, that stuff is all going to end up cached on the thing, and I don't have to worry about moving stuff to an SSD drive off of a larger hard drive. Like, it seems like a really great system, and it's and it certainly is capable of doing that. And so that's why I was trying to like not have to buy multiple terabytes of expensive fast SSDs. And unfortunately, the downside is it still has some bugs in that arena, and I have not been able to take the time to really help get the particular bugs that I'm running into sorted out, because it's like it only happens in this combination of things when I'm running QEMU with Windows, and like there's a lot of file system activity and stuff, and it's just submitting a bug report that says like, oh, when I do these 12 things together it doesn't seem to work, I know that's not going to be very helpful in actually solving the issue. So part of what I'm doing is just kind of like continuing to get the new versions of it, and hopefully at some point they will be able to fix the issue that is also plaguing my computer. But I don't know. So the end result is I don't play the games as much as I would like to, even though the machine is set up to do it. And I've gone into Windows. I can start those games and they run relatively well. It could always be faster. I could have a faster hard drive or a faster CPU and stuff, but otherwise it's fine. Yeah, I mean it's definitely designed in a way that I think is really cool. Because I'm just not gonna run Windows as my main OS anymore. I think I'm not interested in doing that, but I would like to run Windows for gaming purposes, and I do some Windows development stuff. So still need access to Windows, and some of those things that I need access to actually do require real graphics capability. It's not just like, oh, I'm gonna program a console program for Windows or whatever. So I can't necessarily get away with a standard virtual machine setup. But such is life. You got to make compromises, and I spent more money because I got 2 different graphics cards in this computer, and not as much money on hard drives. If I had just spent another couple $100s on hard drives or whatever, I probably could have just had 4 terabytes of decent SSDs and still probably have the M2 drive or whatever, and not had to worry about Bcache. But I wanted to take that risk, I guess, and now I get to pay for it. Yeah. So I mean, if you can come up with a scenario where you have enough, if you can put multiple graphics cards in your machine, then you could do that. It's all like the setup that you need for GPU pass through is rather particular. Like, you want to do the research to figure out if the particular graphics cards that you are using are ones that are most amenable to that. Like right now it seems like the AMD GPUs are not the ones to use for pass through. So I have an NVIDIA card that I use for the pass through, and I use AMD for the host OS. So this is all running on AMD, on a Radeon whatever. I haven't found the VMs to be too laggy. You can definitely configure them to have, it just sort of depends on how many resources you can dedicate to it, and whether or not you are properly ensuring that those resources are fully allocated. But if you get everything set up right, you're only talking about a couple percentage overhead, I'd say, on the CPU side. But with the GPU side, you definitely need it dedicated, or it's not gonna. There's nothing that exists right now to do non-dedicated GPU usage that is anywhere in the realm of what needs to be to run a modern game. Yeah, but like, I think all the lagginess that I've seen has been entirely disk related, rather than anything else. At the same time, I haven't done any like deep performance analysis or whatever, like benchmarking to determine if, because I've seen like once or twice a hiccup or whatever when I'm playing, when I've got a game going or whatever. It's a little like hitch for a few frames, and that's very noticeable. But I think that's a hard drive thing where it's like, oh shit, it had to load in a bunch of data, and that data was, I guess, not cached on the M2 SSD. So you're going to notice the slowness of trying to read from the magnetic disk. Yeah, that's definitely, everything's going to be noticeably slower if you're reading from a real an HDD. I don't know if you had a chance, but if you look at the like PlayStation 5 sort of technical deep dive with Mark Cerny, where he goes on and on about the SSD, it really puts into perspective how slow those magnetic disks are comparatively. Yeah, M2 is they're very expensive. That's why I think I really only have a 500 gig in this one, because it's not, I can't necessarily justify a couple $100 for it at this point, not without having a job. But it is impressively, like, I don't know, it's one of those things where once you get used to that level of responsiveness, I guess, then you start to rely on that being the case. Like in my laptop, I have an M2 drive, and everything is, and that's the only drive in there, so I don't have to worry about anything being slow, and it's great. At the same time, it gets super hot. Yeah, if you can get, well, SATA, yeah, I mean, if you can get the 6 gigabit per second SATA 3, I think it is, or whatever, um, that's going to be a very noticeable improvement. Because even though probably your HDDs are on the same SATA but like the bus is capable of it, they're not going to be able to necessarily drive and supply it with enough data to actually make use of that 6 gigabits a second, except if it's in like most drives have a little bit of cache, like 32 megs, 64 megs, whatever. If you're reading out of that cache, then it's good, but if it hasn't put it into that cache, then it doesn't matter how fast your bus is if you are reading off of a disk that takes so long to seek to and read from it. Yeah. Also, I just don't give myself enough time to game. I think I've mapped out time for this weekend because there was a sale on the game Outer Wilds, which everybody has told me is really great. So I'm going to try to force myself to take a break and play that this weekend. I think there's 32 gigs in this machine. Let me see. Yeah, 32 gigs on this one, which is kind of for me what I would consider the bare minimum if I'm gonna run a VM that's a sizable one. Because like when I run my Windows VM for gaming, I dedicate 16 gigs to it, and I got to be careful about having a million browser tabs open at the same time at that point. I'd love to have 64, but it's not really that necessary right now. I'm one of those people that would be very happy to have 64 or 128 or as much RAM as I could possibly manage to fit into this thing. I think would only go up to 64 with the motherboard that I've got or whatever, but that would be really nice. I could run a couple different VMs. At the same time, it hasn't really come up that that's been an issue, and I think if I started running multiple VMs, like the speed at which my hard drive bug would trigger and I would just have to shut down the computer would be shocking and make it all pointless. So I'm not even going to bother trying that. Where was I at? So we're going to read RSP. We're going to write to what RSP was before this call. So RSP has a value here. It has been very annoying, yeah. Do we do anything to RSP since then? No. Okay, so if we write to RSP here, then we call into here, and we subtract from RSP. That's fine, because we'll just add back to it before the ret. So I think we just want to write to the address that we read minus 7 bytes, let's say. What do we need to do to get back to the beginning of this function? We're at 8A15 is the beginning of do leak. and the address we'll go to is 8A-B2. So if we just write the low byte instead of B2, we'll overwrite it to say 15 hex, then that should be okay. And that we can test that and see that we're running the do-leak function twice because it'll prompt us again. Okay, so what does it look like when we run the program again? Okay, we get a prompt that is like bracket or greater than and a space. Then we'll send line 1 to get the stack leak. And should have just run through it. Okay, and then we will read everything until the new line. So then is going to be receive until read that as a 16-bit value. Okay, then we want to receive until the address prompt, and we want to say proc dot. I wonder how the address gets interpreted. Didn't actually bother to look at that. So it's going to read int 4. And so we just need to send it as a, presumably a decimal integer for A2L. Okay. So we'll send line of the string version of RSP adder -6. Yeah. And then receive until, I think it's another prompt like that. And what we're going to send is let's do just A. Can we do it that way? Let's do it as bytes. A times 7. Oh, and this needs to be -7. Dot encode plus $15. All right, so we'll get the stack address. We'll write to that address -7 bytes, meaning since we're writing 8 bytes, we will overwrite the low byte from whatever that was at that address, which should be the return value, or the pointer to the instruction that we're returning to at least. And so then we will overwrite that low byte with 15 hex, which should take us up to the beginning of the do leak function, and it'll prompt us again. So we should be able to see that it prompts us. Okay. Nothing called rev until. That's fair. Been just typing that wrong. What is it called? It's not called keep. Receive until drop equals true, apparently. Okay, so now we want to say 2. No. Okay, we got a seg fault. So something went wrong with it. We aren't writing to the place that we anticipated we were writing to. Let's do a pause. I'll run it, and over here, you know what? I actually want to keep this open. What is it called? Insomniac. Linus didn't make Linux. Hey, how's it going, man? My day was all right. I didn't make as good progress on this coding project that I'm doing as I would like, but sometimes that's how it goes. You just gotta sort of noodle around what your plan is, or what, you know, it's, I don't know. Need to figure something out, and pushing myself on it wasn't making it happen, so taking a little break, I guess. I wouldn't call it lazy. You just like, you gotta understand when, you know, when the information is there in your brain, when stuff is going, is not going to be 100% of the time, I guess. Yeah, I mean, if you're really tired, the learning isn't necessarily going to be that helpful. Like, will it stick in your brain or not? I don't know, because it makes me think about, like, if you're at school and you want to really cram for a test the night before, and you stay up and you try to learn a whole bunch of that stuff and just keep reiterating on it, like, maybe it will stay in your brain long enough to get through the test, but it's not going to be in there in any long-term capacity. So, when you're feeling tired, you should probably listen to your body around that, and not try to force yourself. If you're not in this, like, I don't know, emergency scenario. So we want to get to what happens after the read. So we go to, we can do do overwrite plus 77 just before we modify RSP. We'll run it, and see you, Fiasfoon. Thanks for coming in and talking with me, man. Hopefully I'll see you on when I do another stream at some point. If you want to come back on the weekends, I'll be doing more of the general cybersecurity kind of stuff with the Try Hack Me rooms and all that. And you can watch me struggle with those and see that, even though what I'm doing here on this stream is very advanced, I can also struggle just as hard on things that aren't necessarily that advanced. Yeah. I'll do try to hack me stuff over the weekend. That's generally what my schedule is. Yeah, we could work on stuff together for sure. Okay, so we're looking for our data in RSP. I guess right now, if we add 18 to it, we have not written to where RSP was. Is that correct? Well, I wrote something. How did we write? Did we write the 15 here? And this got overwritten with zeros. So that's plus 16 bytes from where we wanted to write. So maybe we subtract 16. But shouldn't this take us back to, yeah, why is this 40 and not 48? That's weird. I don't know how that got written to 48. Or rather, I guess 0A instead of 8A. Okay, so let's see actually before we call read. So it's 71. We'll just continue and it's going to segfault, and that's fine. And we'll run it again and attach 2108. I am 33 now. Yeah, getting old. Okay, so what do we have in RDI? 0, so we're reading from standard in. Ah, cool. Yeah, yes and no. I mean, 20 does seem like a long ways away at this point. So there's definitely times where it seemed like it was going fast, and there's times where it seems like, oh, there's been so much. Okay, I think RSI is the pointer that we are writing to. So that is at 559B9. Weird that it's offset by 1 like that. Well, I guess we did subtract 6. So it was originally, oh, we have it right here, right? It was C0, yeah. Oh, yeah, I mean, that's an understandable feeling, that, feeling like, oh, I've wasted time and I don't know what I'm going to do with my future. I felt the same way when I was 20. All I can say, and I don't think that the kinds of advice that you tend to get from people that are older ends up being very meaningful, at least in my experience, even though I can look back on it and go, oh, that's, there was a lot of good, like, it makes sense now, but it didn't make sense then, kind of thing. So me telling you this stuff probably isn't going to be that helpful. But the feeling of how much time you've wasted right now is going to become relatively minor compared to the feeling of how much time you will feel that you've wasted 10 years from now. And I'm going to assume that continues. I'm going to end up being 40 and feeling like, oh, I wasted a bunch of time in my 30s. Even though right now what I'm trying to do is avoid that by feeling like I'm doing stuff to not waste my time. I'll probably just think about things differently and be like, all that effort I spent to eventually feel like I had really meaningfully spent the last decade, I will go and be like, oh, that was making me spend it in a way that turns out not to have been meaningful or something. I don't know. I'm just not going to think about things the same when I'm 40 if I get there. And so, that's just how it is, I guess. Yeah, I'm sure that at this age you can already see that pattern of like, oh, people told me this and that and the other thing, and it didn't make sense, and now it does make sense. That's still going to be true, presumably through most of your life. I mean, at some point, if you live long enough, you're going to be 70, 80, whatever. There's not going to be somebody who's 100 who's like, well, here's what you really need to understand at 80. But certainly if you live through 40 and 50 and stuff, it's probably going to be true that, there's more understanding and deeper wisdom or whatever that somebody who's older than you has acquired, but can't really express that to you in a way that's going to be meaningful. Unfortunately, we all just got to live through the life that is ahead of us. Like, it would be nice if there was some shortcut through it, but it doesn't seem like that is the case. All right, so the address we got was C0. And so if I just continue and then do one more instruction, and now RSP is pointing at, interesting. Is this another case of like it's not always the same kind of offset? That's gonna be annoying. All right, see you later, dude. I'll be here for another hour or so probably. Especially if I don't get this solved in the next hour. Okay, but RSP is at B8 when we started at C0. So really we wanted to subtract 8 and 7. So let's give that a shot instead. So an F. Weird. Okay. Or so wait, if we got C0, and the value we want to write to is starting at B8. I'm going to subtract 8. I'm going to subtract 7, so when we write the 8 bytes, yeah, that seems right. But maybe it's just a little bit random. It seems consistently to fail. Okay. So the address that we got was E20 this time. And what we have in RSI is E11. Okay. And then we are writing one too many. Are we getting the /n in there? Guess we don't want to do send line. All right, so we got 740 is the stack address, and we're going to write to 731. Okay. Should write through 739. And we are still writing too much. Okay. Why is 7 of these too much? Alright, so 560, I'm writing to 551. Makes sense. Then go to 558. Sure, and we've overwritten that with the 15 and the low bytes, so that all looks good. Oh, it's reading in 8 bytes. I see. Because we did a send line on this one as well, but it's reading in some fixed number of bytes, not including the end line. What? So we can provide the fill character. Okay, so if we say yeah. I think this needs to be F, because we are going to read in F bytes, so yeah. And we'll R adjust it with 0. And then here we can send 7. Do I have too many or not enough? Parentheses, apparently, yeah, okay. Okay, so R just is not defined on a string. Oh, I already put in an R just, okay. There we go. So yeah, we'll start writing at B1. And then, cool. Now we should have overwritten the low byte with 15. So okay, so it's now working, I guess. And we can say 2 this time. Cool. Now we can get the address of the doLeak function. And from there we can calculate the address of the doOverwrite function. Of course, when we have doOverwrite, we can only do one write per sequence of calls. Although this read lets us read in 15 bytes, does that give us anything? Well, this writes to the beginning of RSP, but it's going to then add to RSP. we could get like a 2-element. We could control 2 like return addresses basically. After we leak the PIE address, then we know what all of this stuff is. And so we can get those bytes. And if we do a partial write that leaves the low bytes of this, maybe the low 2 bytes, we could choose an address to jump to, like a gadget that happens to have these in the low 2 bytes or 15 in the low 1 byte. And because we're writing 8 bytes, we would then overwrite 1 or 2 bytes of the next return address. Meaning, basically, we can find a gadget somewhere else in the text segment that has 15 as its low byte, if there is a meaningful gadget for us with such an address. And then we could control another single gadget, assuming that the like byte above it was also 7A. Well, wait a second. Okay, so if we want to return to, if we want to go through do leak again, oh, and the low byte's not going to be 15. It's going to be, it's going to be B2. So we can find an address that is also B2, which might be easier done with this mode. What address are we at? So yeah, do leak is there. Do overwrite. Could do read int at this address, I guess. There's no B2, unfortunately. I mean, we could jump to B2, which would interpret these bytes entirely differently. And I don't know if that would be helpful. But yeah, we could find a gadget that was okay for with B2 other than the normal one. I'm just trying to figure out how we can get multiple writes out of this, because I could loop back to do leak, or I could loop back to the beginning of the do override function and repeatedly write a single 8-byte value, but in order to go back to that function over and over again, the 8-byte value that I have to write is like, I have to use the entire, or pretty much all of the 8-byte write that I have access to in order to achieve that looping behavior itself. So I don't know how I get a side benefit out of that. I don't know how I also write other stuff that is meaningful. let's look at so the most obvious thing would be to maybe not jump to the beginning of a function. And that's where we start having weird stack behavior, because if we don't have the sub RSP18 hex, but then we do the add RSP18 hex, then we're sort of like going off. The stack is becoming less and less like what it's supposed to be in normal execution. Oh, there we go. I guess depending on what we have in RSI after the read, if we return to another read, or yeah, so okay, let's do this one again. Then after the read, what do we have in RSI? I think it is the same address. Okay, that is helpful. What do we have in RDI? Same value there, and RDX. Okay. Hmm. So we could jump right back to the read call, but it's going to read to the same memory address. And we're going to be adding 18 hex to RSP each time, which then means it's not using the value that we are overwriting anyways. So I don't think that's a fruitful avenue. Hey Food Carol, how's it going, man? Pwn course? Yeah, still working on the Nightmare Challenge stuff. We're in the ROP section, trying to get through that. We haven't done any heap exploitation yet, but yeah, welcome back, dude. This one is really, I'm not sure how to make use of this single write. In fact, the only thing that I've been able to figure out so far, I got a pretty clear hint on from looking through a little bit of the walkthrough. And so I was able to make use of the thing that they said, hey, we're going to do this. I didn't keep reading, so I don't know what the further steps are, and I'm still having trouble working out what those should be. I think I'm just not in the right headspace for it right now or something. I guess we could jump into the read function. What does read do? Read subtracts 38, so when we go through all of it, it's going to add 38 at the end, I'd say. Yeah. That's not going to be helpful. So where is a good place to jump to in order to, like, we're stuck with the same, is there one useful place that we can jump to? And it just seems very unlikely that that is the case. That seems like the two avenues that we have. Either I can figure out how to make use of this to repeatedly write 8 bytes somewhere on the stack, I guess, and then jump to that. Or no, we can't jump to it, and we can't, and I don't know where. I mean, there's probably a gadget that we could return to that moves a certain value into RSP, maybe. So maybe we can find that gadget and return to that address, return to a stack address that we control, and then we're in our ROP chain. But before that even becomes relevant, I need to find some gadget, or I need to find some way to make use of this single 8-byte read call, single writing 8 bytes to memory that allows us to do it repeatedly without having to use that 8-byte write to achieve the repeatedness. to achieve the looping of it. And it's not occurring to me how to achieve that. And then the alternative is we find something, some spot that we can just return to in the binary that does everything we need. And that also seems very unlikely. Well, I'm gonna go back to the walkthrough because I don't know. I'm not feeling like I have good ideas. Oh, they'll use the finish array to give as many rights as you want. Okay, how does that work? If we I don't like I understand the idea of like, okay, now that we've leaked an address within the wherever the binary has been loaded, we can calculate the address of the Finney array, and so we can write into it. But what are we at writing into it that gives us a looping something that allows us to write as many times as we want? There's some other function in here. Seems unlikely. It does get called in various places. This is in what function? Discover OS version? What is it reading from? Okay. Just whatever file it opened. Okay, that doesn't seem useful. Trying to see if there's other stuff in libc that calls read a bunch of times, maybe, but that all just seems besides the point. How do we use the Finney array to do stuff repeatedly? I don't know. I'm not feeling it today, so I need to write 2 entries to the Finney array. So I was operating under the basis of thinking we could only write 1 entry. So let's see. So we get the stack leak. Calculate the address. Oh, interesting. Look at that. Hmm. Yeah, this part I don't get. Okay, so this one just goes back to I think they just typoed it here, but it goes back to do leak. So they're doing the same thing as up here. And then we leak one again. It doesn't really matter which one we choose at that point, because we don't care about the result of the leak. Then on the third overwrite, we overwrite the second entry for the Finney array, which gets executed first. So we do this right, and then the program exits appropriate, like normally. And when it goes to the exit, it ends up running the do overwrite function again, which allows us to overwrite the next entry in the array. Okay. I see. All right. Okay, so the issue that I was dealing with is if we that is pretty clever. Okay, I need to like try to retain that in my mind as a mechanic that we can use if we have leaked enough information to be able to know where the Finney array is. So if we use read to control where this ret pointer goes, for example, and have it loop back up to the do leak function that'll eventually call back into here, well, the way that the stack has been written, this ret pointer is now going to point back to the same correct address it should be returning to. So in order to control it a second time, we would have to rewrite the stack address where it's using the address from, taking the address from. Meaning that every single cycle, our only write needs to be used to achieve the cycle again. And that was the problem that I was dealing with. Like, we need to use our write to give ourselves the next write, and we don't ever get the ability to write elsewhere in memory as a result. But if you write to the finish array, the list of functions, that array doesn't get reset. So every time the program tries to exit, it will then run through the finish array, and we can effectively loop it through that. Yeah. Because we can write there once, and repeatedly it will be able to reuse that address to call the same do overwrite function. Okay, that is doable, I guess. I mean, it's definitely doable. It's just a matter of, am I going to be able to achieve that right now. Yeah, let's give it a shot. So then it's one of the, I mean, it comes back to you pretty quickly, I feel like. Yeah, Python is a relatively easy language to get into, although I've been writing enough Clojure that I am missing some of the niceties from that language. I feel like that language is like really well designed. But such is life. Pwn tools is a Python library, so I'll just have to write it in Python. Alright, so we've got one function here. We can say then we can say def write adder and value. So we might as well say write okay, so then we want to say write do stack adder and Do leak adder is leak false. And then base adder is do leak adder minus binary dot symbols do leak. Base adder. All right, then we'll have to figure that out. Okay, then FA adder is base adder plus binary dot symbols. Do global detours aux Vinny array entry, I think. So we want to say write do leak no, we just want to do write. Is that true? Or do we want to go back through again? Does it matter if we go back through again? I want to say also so we want to write to FA adder plus 8 for the second entry, the overwrite adder. So this will write to the second entry in the array, which will be read first, and then, or there'll be run first, so then we'll call do overwrite, which will allow us to do a second write to write to this the first entry in that array. So when it returns the second one, so like this is paired with the do leak call that we did here. This is from the first call to do overwrite, and then we want to call to All right. Unfortunately, I don't think I'm starting to add up all the stuff that I need to do in my mind, and I just don't feel like I have it in me to finish all of that this evening. Unfortunately, it's about 11:30, and yeah, I've just been, I don't know. Today's not been a high energy day for me, so apologies for just not really. It's kind of a whatchamacallit, like my brain is not here. I'm not even able to formulate the right sentence. It's kind of a letdown ending. But the things that I need to do are, I need to, oops, where am I at here? I need to write the CSU. No. Oh, I want question mark, or not question mark, or tilde. libc csu fini return ret adder with libc csu fini we can get that one right now. So I need to calculate what the address on the stack is for where the finish function will return to, what its return value is. That seemed to be something that was in the like the actual exploit from the write-up. I am like not, I'm trying my best not to just follow exactly what they did, but instead to actually go through the steps myself based on the explanation. And I mean, I read through this because I was having trouble grokking the explanation, but now that I get what the mechanic is, I would rather actually go through the whole thing myself. But it does seem like we need to have a way. Oops. We need to have a way of controlling when libc csu fini, which is going to run through that fini array and execute or do a call on each of the entries in there. When it has finished, we need it to return back to where we need it to return back to the beginning of itself so that it will run through that array again. And I just need to figure out what that looks like, it just in GDB basically, and calculate the offset from where the known leaked stack address is, basically. Which they did, and they calculated as some particular number, but I don't know if that's going to be the same because some of their other numbers weren't exactly the same as what I had worked out. So I'm not going to rely on an assumption that what they have in their exploit code is exactly the same as what it would be on my machine. So that's one piece. Then we need to generate the ROP chain and loop through doing the ROP chain writing, which is fine. we probably don't even need to do a special function for it, actually, now that the more that I think about it. But so I need to put together that wrap chain, then put together the code that loops through and does the necessary writes, writing a wrap chain entry somewhere. We need to figure out where in the stack that we'll write to. And then lastly, we need to, instead of writing the Finney address return to go back to the beginning of that function, we needed to go to a gadget that pivots our stack pointer to the beginning of our wrap chain, basically. And that last piece, I really don't know what is necessary for that, but I think it's something that I could work out on my own with enough just trying different stuff, looking through the wrap gadgets that are available, etc. But all of that's probably going to take another at least half an hour, if not a full hour, to get through all of those pieces. And I just don't think I have it in me to continue on with that right now. So we're going to have to finish this one up on the next stream where we do hacking stuff, which is going to be on Friday. So again, apologies that there was not a lot of progress with stuff today. It was just this one challenge and a lot of nothing, and then a little bit towards the end when I just started working through what the write-up had for me. But we'll get through this, and I think there are some interesting techniques that obviously hadn't occurred to me. The one that the first thing that I got from the write-up, I should have maybe pushed myself a little bit more, because that was all things that I knew how to do and had sort of thought about, but hadn't really thought about far enough to realize that I could do them, I guess. Doing the partial overwrite to get back to looping again. Like, we've done that a couple of different times, at least at this point, so it probably should have come up as a mechanism that I could have used to get both of the leaks. But then the stuff with the Finney array, even though we've done stuff with it before, at least I think just one time, it wasn't really, that was pretty far outside of what I was thinking. It had briefly gone through my mind much earlier on of like, oh, maybe we could do something with the exit functions, because I remembered we had done a challenge like that. But using it in this fashion was really, it seems pretty novel from my to my experience. So all in all, this is definitely an interesting challenge in terms of what techniques I need to learn to be able to make use of it. I don't know how much these techniques will apply outside of this one challenge, but it definitely is a nice challenge, and so I'm looking forward to completing it on the next stream on Friday. Before then, though, on Thursday, we're going to go back to working on the x86 decoder, which has been moving along. I mean, I guess I could say kind of slowly. It's not like I'm, have tons of instructions working, but it's been solid progress on every stream, so I feel good about it. And maybe sometime in the next decade or so, we will have a decent amount of instructions working, and we can start trying to decode some real stuff from an actual binary or something. In any case, that's everything I have on this stream. I'm gonna go to sleep probably. If you can't tell from from my voice, that very low energy right now. So yeah, thanks for watching. Thanks to everybody that popped in and chat and was talking with me. I really appreciate that. It's nice to have a little bit of an audience and people communicating with me. So hopefully I can see you all on the next couple streams or over the weekend when I do the Try Hack Me stuff. Adios.